Algebra 2, Lesson 52, Chemical Mixture Problems. Now these are just like our substitution elimination problems, but we're adding a chemical mixture to the equation. So in our practice, they tell us a chemist has one solution that is 25% salt and 75% water, and another solution that is only 5% salt. How many milliliters of each should the chemist use to make 1600 milliliters of a solution that is 15% salt? So this all sounds like Greek at first, but we just need to know how to write our equations. We need to write one equation in terms of salt content, so because what we're trying to get is 15% salt in the end. So we're going to write one equation in terms of percentage of salt, and then we're going to write another equation in terms of volume, because we need a specific volume of this 15% salt solution. And using that, we'll be able to substitute and eliminate and find out how much of each solution he's going to need. So starting here, equation 1 will be in percentages, and we'll just make this the practice. So they tell us the first solution is 25% salt, so we can write 0.25 times, we'll call this solution A, or we'll call it solution 1, or salt 1, and then we have to add that to the percentage of the second solution, which is only 5% salt. So we'll call that 0.05, and that'll be salt 2. And that will equal 0.15, our ideal amount will give us 15% of our final salt solution, so salt final. And the way this first equation is set up is if we take 25% times the volume. So these are going to be volume amounts. So the unknowns are going to be the volumes, because that's what we're looking for. And then if we look at the equation, they tell us they want 1600 milliliters of that 15%. So we can replace salt final with 1600 milliliters. So that's our first equation. 0.25 salt 1 plus 0.05 salt 2 equals 0.15 times the volume of our final salt solution, 1600. Then we have to do the other equation in terms of milliliters only. So that one's really simple, because if we add up the volume of salt 1 plus salt 2, we're going to get our final volume of 1600. Alright, from here we're going to be able to substitute and eliminate between the two equations. First thing I'll go ahead and do is I'm going to simplify the salt equation. I'm going to get rid of all the decimals, and so I'm going to multiply everything by 100, and I'm going to copy that down below. So that'll become 25 times salt 1 plus 5 times salt 2 will equal 15 times 1600 for our final solution. Here you'll be able to see that we can do substitution or elimination. Now I'm going to go ahead and do elimination, because that seems to be the easiest one. So if I take this bottom equation and I multiply it by -5, that'll give me the opposite coefficient of this salt 2. So I'll take all of this, multiply it by -5. So that's going to give me -5 salt 1 minus 5 salt 2 equals, let's see here, what's 1600 times -5? I'm just going to go ahead and multiply this one. Times 5, 0, 0, 30, 8,000. So -8,000. Okay. And then to eliminate, we have to add that to our top equation. So it's 25 salt 1 plus 5 salt 2 equals, and I'm going to go ahead and simplify 15 times 1600. So 15 times 16, get 39, add another 0, we get 5 and 1. 0, 0, 0, 0. And we get 2400 milliliters of would be our final. So 16 times 1500, or 15 times 1600 would give us 24,000. From here we can finish our elimination. These are going to cancel. 25 minus 5 gives us 20 of the salt 1 solution. Whoops. And 20 of the salt 1, 24 minus 8 would give us 16,000 of the final. So to find the volume of the first salt solution, we divide by 20 on each side. We can cancel one of those zeros. 16 divided by 2 is 8. So 800. So the first salt solution is going to equal 800. Now to find the second salt solution is very, very simple. We just have to remember that salt 1 plus salt 2 equals 1600. So 1600 minus 800 is another 800. So salt 2 is also going to be 800, and this is in milliliters. So that would be our answer.